All right, so we'll start our recording here. Now we're in uh, section 5.8, integration using tables. So you have learned from sections 5.5, 5.6, and 5.7 some good integration techniques. And mathematicians over the years have used these techniques to discover integrals. And as they discover integrals, some of the mathematicians uh, basically put their results, recorded their results for others to use. As they discovered new antiderivatives using these techniques, these integration techniques, they would record their results in tables so that other mathematicians could use those tables, like engineers could use those tables. I remember my father, when he was in college, he had tables that he used in his classes. I mean, he showed me his book of tables, you know. There are whole books of tables that have formulas and integrals and so forth, antiderivatives and all that. We're going to be utilizing that table here. So let me give you a moment to copy the example down. Our book comes with a table of 120 formulas, antiderivative formulas. Let me give you a moment to copy the example down. Okay, so we have here an integral, and we want to solve the integral. Now, you know, to solve this integral would require trig substitution, which you've not learned, but nevertheless, we can use a table of integrals to help us. So tables of integrals are to be used only for section 5.8 problems. And let me go to the ebook here. Let me show you how to access this table of integrals. So let me see here. Let me go to the ebook. Okay, so all right, there's our book. And now computer algebra systems are something when you take your math, your higher level math, you'll learn you'll learn about MATLAB. That's like a computer algebra system. We're sticking to tables here. Tables are good. You know, they're helpful. So in the ebook, in the table of integrals there, section 5.8, they mention here that a relatively brief table of 120 integrals categorized by form is provided in the reference pages. So if you click on that link, reference pages, it brings up this reference pages link. And it's like the appendix. I mean, there's that those trig reference pages, but what we want is we want to click on table of integrals. If you click on table of integrals, it'll bring up a table of integrals, and there are 120 different integrals in this table, and they're separated by form. So, like for instance, there's forms involving the square root of a squared plus u squared. There are forms involving the square root of a squared minus u squared. Okay, so what we want to do is, oh, well, and I'll mention something else too. There's another way you can access tables too. If you go into Blackboard, if you go into the Blackboard, hold on, okay, go into the Blackboard. If you go to your course content, click on Chapter 5, Integrals. There's a link for Section 5.8, Integration using Table and Computer Algebra Systems. And if you click on the link there, Table of Integrals, it should bring up a table of integrals that you can download. It's the 120 formulas that you see in the reference pages. Okay, so when you do that, when you click on that link for table of integrals, you should be able to download a table. So let me see here. The table. Let me see. Where is it here? One moment, class. Yeah. How many are seeing a table that looks like this with reference pages when they click on that link? All right, Clay is seeing that. And IB and saying, okay, good. So that's another way to access a table of integrals. And what we want to do for this, and everybody should try it, right? What we want to do for this problem, how did you get there? Course content, Mandy, go to Chapter 5, click on, under course content, there's a link. Hold on here. So I showed this, but I'll show it again. Hold on. So you go into your Blackboard, and there's a, your course content folder is right here. Okay, click on the link that takes you into Chapter 5 course content, the here link. Go to Section 5.8, and then click on the Table of Integrals link, and it will bring up that table of integrals. All right, so what we want to do now, is we want to locate a formula from this table of integrals that's going to help us break out this integral here. Okay, so what I want you to do is I want you to look through your formulas and tell me when you think you have a formula that somewhat resembles this integrand. Oh, what, Clea, what'd you say? 15?
18.
15, all right. So let me just see here. Let me look at that number 15.
I said 18.
Oh, 18, okay. Hang on, 18. So let's take a look. And Mandy thinks 18 also. All right, let's take a look. So formula 18 on the left side of formula 18, you have 1 over u times the square root of u squared minus a squared du. So the variable is u. So in our integral, we do have a variable here. If we were to let u equal 2x, okay, if we were to do that, then this 4x squared would be like u squared, and the 7 could be like a squared. That's a constant. But the problem is you have this x squared here. You have a variable squared, and this u here is not squared. This u here is not squared. So formula 18 is close, but not quite right. Good try, good try. Formula 28, the problem with formula 28 is, okay, so well, let me just see here. If I put down formula 28, and then I saw that formula 36 was mentioned also. On formula 28, you do have okay, one moment. Saeed says 45. So Mandy, that's almost right, but what's the problem? What's the problem with this choice of 28? What doesn't match?
We have a 4 before x squared.
Well, that's not a big issue, but
Oh yeah,
we have a minus here.
oh yeah, it's u squared. We have only minus 7.
Right, so Clea, we can do a substitution to take care of that 4x squared, but formula 28 has a plus and we have a minus. So almost right, almost right. Now 36 was mentioned. 36, let me see here. The problem with 36 is, so 36, instead of a plus, you have a minus here. But the problem is, there it's almost right, but something I didn't mention. You have a constant term coming first and a variable term coming second. Here, the variable term comes first and the constant term comes second. So that won't work. But 45 was mentioned. Good try. Hold on now. Who was our Susanna? Good try. I'll tell you what, Shalom. Let's look at Saeed's number 45. 45 is actually going to be the right answer. Let me show you why. Formula 45, here's formula 45. So in our solution, here's formula 45. And what we have to do is we have to modify our integral. So let me give you a moment to copy down to here. Let me give you a moment to copy down to here. The problem with Shalom with 57 is that there's the u is not squared. You need like a variable squared for this to work at all. So good try, good try. Okay, so what we're going to do, like when I look at formula 45 and I look at my integral, I say, well, okay, if I'm going to apply formula 45, where the 4x squared goes, I have to write that as 2x quantity squared. And so u would equal 2x. Okay, and then you know, I'd have my u squared. The 7 here is the a squared. So 7 is like root 7 squared. So a is equal to, just a. That equals root 7. So these problems in section 5.8, we have to make substitutions to help us. You almost never can apply the formula directly. You try to find a formula that's a close match, but then you have to make a substitution. By letting u equals 2x, 1/2 du equals dx. And so my integral with respect to x can be converted to this integral with respect to u. So first, let's talk about the limits. The original limits are 3 and 2 for the original integral with respect to x. The new u limits are going to be, well, 2 times 3, which is 6, and 2 times 2, which is 4. Okay, so now what about the x squared here? What about that x squared? Well, if u equals 2 times x, then u divided by 2 equals x. So that's how we get this u over 2 here. Okay, so we're going to have to do a little bit more before we can apply the formula directly, but we're on our way. We're on our way. Please let me know if you have any questions. All right, who's okay so far? Okay, Clay is good. Avery's good. All right, so we get down to here, and we compare that integral with, the matching integral here for formula 45. And we got to do a little modification, Okay, so let me go to the next page. All right, let me go to the next page then. So the u over 2 quantity squared, I'll write that as 1/4 u squared. Okay, and of course I have a half here. I'm going to bring that 1/2 out in front of the integral. And then we have here, we have 1 divided by 1/4. That just equals 4. So 1 divided by 1/4 is just equal to 1 times 4 over 1. That just gets you 4. And so that's what we have here. Well, yeah.
Professor?
So, yes, Claire.
How did we get 1/4 again?
The 1/4, the way we got it is u divided by 2 squared is u over 2 times u over 2, which is u squared over 4. That's how we get 1/4 u squared. But the 1 divided by a 4th, that's just equal to 4. And so that 4 then, I can bring out in front of the integral. See, I bring these nuisance terms out. And now at this stage, I'm ready to apply formula 45. Formula 45, let me just rewrite it here for you. So formula 45 is the integral of 1 over u squared times the square root of u squared minus a squared du. So our variable is u there. Yep. That's going to equal the square root of u squared minus a squared, all divided by a squared times u plus a constant. And so you see, by pulling out those nuisance terms, you know, here's my integrand, and that matches the integrand here pretty nicely. So now I apply formula 45, and you see here I put a formula 45, I put it above the equal sign. That tells you that I'm applying formula 45. Now, the 1/4 times a half, that just equals the 2 here. And then I applied formula 45. Please let me know if you have any questions. So Jonathan's asking, could we simplify the square root of 9 over 4? Yes. So, I mean, this answer, WebAssign would take this answer here at the bottom. But I agree with Jonathan. Why don't we distribute the 2/7 and simplify the square root of 9? Of course, if WebAssign said in simplified radical form, it might want that square root of 9 as a 3. I'll go to the next page and show you that. IB, question?
I have a question. So when we're doing integrals by using tables, do we have to memorize um, the formulas, or
Oh
we
no,
follow
no.
tables?
You will have this. You will have this on your exam. So like the exam, you know, there'll be a part 1 and a part 2. Probably part 2 will have section 5.8 on it, and you will have access to the tables. I will make sure you have access to the tables
All right, thank you.
for section 5.8. But only use the tables in section 5.8 now. Don't use them for the, you know, earlier sections.
I understand.
All right, very good question. Very good question. Are there any other good questions? Okay, well then let us proceed on here. Let's get this answer in a little bit nicer form. So we had, let me see, our integral was equal to 2/7. Well, Xavier, we don't need to plug back in u, because we changed our u limits to 6 and 4. We plugged those in, but our answer isn't going to have a variable in it. It's going to be an actual number. You see, it's going to be an actual number because it's a definite integral. Okay, good question. So we had what? Square root of 9/4, that's 3/4. So we distribute the 2/7 across the two terms. And that's going to get us this here. 2 root 29 over 42 minus 6/28, but we can make it look a little nicer. And then here we go.
Can you please go back?
I'm sorry, IB?
Please go back.
Yes. One moment.
All right, thank you.
Okay, you're welcome. Then we get here. All right, are there any other good questions? All right, well, of course, we're going to do some more examples from section 5.8 in Wednesday's class. But let me go ahead and stop the recording here.